Graph a system of inequalities. We have x plus y less than 4, y less than or equal to x, and y greater than negative 1. So let's go ahead, graph each inequality first. So you have x plus y less than 4, that's the first inequality. Now we need to graph the boundary line. The boundary line is x plus y equal to 4. So we replace less than with an equal. You may want to graph any way you want to. You may want to write it in slope-intercept form. So that would be y equal to negative x plus 4. And you figure out the slope and the y-intercept. But I think it would be very easy to just figure out some of the points so quickly. If x is 0, this disappears. You're left with y equal to 4. When y is 0, this goes away. You're left with x equal to 4. And you can select any other point. So for instance, when x is 1, y is 3. If you figure it out that you have 1 plus 3 is 4. Or 2 plus 2 is 4. So anyway, you can easily pick points on the line here. So you have 0, 4, 2, 3, 4. This is 1 point, 4, 0. And you have 1, 3. And then you can, these are points on the boundary line. If you take a look at the first inequality, you realize that the boundary line is not included in the solution. You have a dashed line. If you recall, a dashed line, because you have less than 4, it's not less than or equal. So plotting draw the dashed line, and here's the boundary line for the first inequality. Now you may want to know how we can shade above or below the boundary line. So you might want to use a test point. Which test point you want to choose, it's up to you. Let's go ahead and pick 0, 0. Because that's not on the line, so we can select 0, 0 in here. And then if you plug in x equal to 0 and y equal to 0, you can plug it in the inequality. So you have x plus y less than 4, so 0 plus 0, is that less than 4? 0 plus 0 is just 0 less than 4, so that's a true statement. That's true. 0 is less than 4. So that means the test point that we picked, 0, 0, is included in the solution region. So since this is in the solution region, we have to shade below the line. So that will give us the graph of the first inequality. Now we can pick the second inequality. We have y less than or equal to x, and we can find the boundary line. The boundary line is y equal to x. Y equal to x, whatever x is, y is. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2, and so on. You can go also select when x is negative 1, y is negative 1. So these are the points on the boundary line. Now you realize that the inequality is less than or equal to x. So the boundary line is included in the solution. So this is the line of the boundary line. It includes in the boundary line. So that's why we have a solid line. Now you want to choose a test point. What test point you need to choose Now we cannot use 0, 0 like we did in the first inequality because 0, 0 is included in the solution. So we have to choose to use other points. So you might want to choose 0, 1 or 1, 0. I'm going to select 1, 0. So if we select 1, 0, that means x is 1, y is 0. You plug this in the inequality, you get y, which is 0. And is this less than or equal to x, which is 1? Yes, 0 is less than or equal to 1. So that's a true statement, which means the test point 1, 0 is included in the solution region. So 1, 0, that is below the boundary line, is included in the solution region. So we shade the region below that line. So this is the graph of the first inequality. Now the last one, you have y greater than negative 1. The boundary line is y equal to negative 1. If you recall, this is a horizontal line. X, no matter what x is, you get y equal negative 1. When x is 0, y negative 1. When x is 1, y is negative 1. When x is 2, y is negative 1. And so on. So whatever x is, y will always be negative 1. And y is greater than negative 1, which means the horizontal line is not included in the line. I mean, the boundary line is not included in the solution, so it's going to be a dashed line. So let's go ahead and graph a dashed line. And we need to know whether whether we shade above or below the line. Since y greater than negative 1, anything above that line would be greater than negative 1. So you have to shade above the horizontal line, y equal negative 1. If you take a look at the graph, you realize the shaded area in all cases. So this is below that line, below this line, and above this. So it's going to look like this. It looks like a triangle. Here's a solid line. This is a dashed line right here, and here a dashed line. So here, right here, is a solution of the system.